Hi guys, today we're going to take a look at page 17 of the Unit 2 Classwork Packet. We're going to be continuing with reflections, right? A rigid motion transformation, which keeps the figures the same size, but, just changes where they are on the XY plane. And we're going to take a look at reflections over lines other than the x-axis and the y-axis. Let's go. Okay, now the nice thing about these is, guess what? There's nothing to memorize. There's no coordinate rule. All you got to do is graph and count. Let's see how this is going to work, okay? Before we start, though, there is one prerequisite thing you need to know from Algebra 1. And let's see what that is. In Algebra 1, okay, you guys learned about two special cases of lines. X equals, let's say, 1. And, I don't know, let's say y equals 2. Whenever you have x equals a number, I know this is going to seem kind of counterintuitive, but x equals a number is actually just going to be a vertical line. Let me say that again. X equals a number is a vertical line. Vertical means up and down, people. Yeah? By contrast, if I have y equals a number, I know it's going to be counterintuitive, meaning contrary to what you might think, but that's going to be a horizontal line. All right, so in this case, just like this. Okay? Now, I go over that again because that's a prerequisite, meaning you have to be able to know how to graph those lines in order to effectively transform the reflections, the figures we're going to, talk about now. So with that being said, let's take a look, guys, at question number 5. What number? Number 5. Okay. Oh my gosh, why is it so smudgy? All right, now number 5 gives me a triangle. Okay, let's draw this. And again, please don't criticize me too heavily. Okay, I do my best, but I don't know where I don't have a magnet here, so I can't use my nice magnetic graph. 2, 3. Okay. And 3, -2. Alrighty. So step 1, well, you got a graph, right? And notice how instead of saying reflective of the x-axis or reflective of the y-axis, they actually gave me a different line of reflection. And that line of reflection was x equals 4. So what I'm going to do is I'm actually going to graph that line of reflection. Why is it up and down? Because x equals a number gives me a vertical line. So now, guess what? In order to perform this reflection, all I gotta do is do exactly the same thing I did before by counting. Let's see what I mean. This point right here, okay, is how many units away from this line? 1, 2, 3. So on the other side, how many units think it's gonna be away? It's gonna be 3 units away from the line. This one is really nice. It's only 1 unit away from the blue line. So on the other side, it's going to be 1 units. And over here, this is originally 2 units away. So it's going to be 2 units on the other side. And to find the coordinates, well, guess what? If I'm using graph paper, which unfortunately I didn't here, but we just read them from the graph. So 1, 2, 3, 4, 5. Okay, so this one right here is at 5, -2. 4, 5, 6, 7. Okay, this one's at 7, -1. And this one over here, 2, 3, 4, 5, 6. I believe that's at 6, 3. All right. So again, as long as you guys remember which way x equals the numbers that way, which way? Vertical. By contrast, y equals a number is going to go horizontally. We'd say flatwise. Just to make sure this is sunk in, let's try one more example, guys, okay? And let's try it with example number 7. We're still on exactly the same page, page 17 of the Unit 2 Classwork Packet, but let's take a look together at example number 7, just to make sure you guys got this. Alrighty. All right, so number 7, they give us a parallelogram Parallelogram. I wonder where I've heard that before. Yes, parallelograms will become a big part of your lives in Unit 8. So much to look forward to, right? Of course. -2, 0. There. 6, -1. 1, 2, 3, 4, 5, 6. Nope. Oops. It was 6, +1. I apologize. And 4, -3. 4, -3. Ugh. Parallelogram. Okay. I know it's not a very good parallelogram, so I apologize. And then they tell me they want me to reflect it over y = 2. So what I'm going to do is I'm actually going to draw kind of like a dashed line here for y = 2. Now notice that these points are below. So that means when I reflect them, they're going to go above. Okay, so this one was 1 below, so it's going to go 1 above. Ooh, this one I actually got to count, right? Let's see. Okay, so this one is 1, 2, 3, 4, 5 below. Hey, like the store, right? 5 below. And then 1, 2, 3, 4, 5 above. So there we go. I know this is not really drawn to scale, so I apologize, guys. Okay, this one over here is 2 below, so it's going to go 2 above. On this one over here, where is that? That's a -4. Yeah, okay. So this one right here is, I think, 6 below. So it's going to go 1, 2, 3, 4, 5. Got to keep going. 6 above. Now, I apologize for my scale here. I know it looks like it got bigger. It really shouldn't have. Okay, that's just because I'm a horrible grapher. But basically, as long as you simply remember that when you perform a reflection, it's the same distance away from the line of reflection on both sides, all you got to do is count. So over here, I think that this new point would be, what is that? 6, 3, right? Yeah, 6, 3. This one would be, let's see, let's count. 2, 3, 4, 5, 6, 7. So 4, 7. This one over here, let's see, -2, +4. And then all the way up there, oh my God. 2, and then we went up, I think we said 7 units, no, we went up 6 units. So that's at 8, right? Yeah, -4, 8. All right, so again, big thing to remember here is which way the line goes. When it's x = a number, vertical, up and down. By contrast, when it's y = a number, across.